Hey everyone, ready to dive into a field that could change, well, practically everything.
I'm talking about quantum computing, of course.
Of course. And we've got this super interesting article from Science Tech Daily. It's called A New Era in Quantum Computing. And, well, it's a pretty big deal.
Yeah, really fascinating stuff.
For sure. Especially for anyone out there, like our UPSC folks in India who, are keeping up with the latest in tech. This is for you. So this article talks about this breakthrough. And it could get us way closer to having these like large-scale quantum computers, ones that actually work.
Yeah, definitely. Quantum computing is like a total game changer, and this is a big step.
Totally. Okay, so real quick, for anyone who's maybe new to this, regular computers, they use bits, right? Like a 0 or a 1. But quantum computers, they use these things called qubits.
Right.
And get this, qubits can be a 0, a 1, or both at the same time.
Yeah, it's called superposition, and it's like what gives quantum computers all this crazy power? Like, imagine you could try every solution to a problem all at once.
It's like flipping a coin and it lands on heads and tails at the same time.
Exactly. And that's how they can like solve problems that would take like millions of years on a regular computer.
Mind-blowing. And the potential, I mean, we're talking revolutionizing medicine, designing new materials, the whole 9 yards.
Right. Totally.
Okay, so the big news. Microsoft, they teamed up with some physicists at UC Santa Barbara, and they just revealed the world's first 8-qubit, get this, topological quantum processor.
It's a huge milestone. Researchers have thought for like forever that this topological quantum computing is like the key to building stable quantum computers, ones that don't, break down all the time.
Now, topological, I know it sounds kind of scary, but it's actually really cool. What makes this kind of processor so special?
Okay, so it all starts with this like new state of matter called a topological superconductor.
New state of matter, like they found a new element or something.
Not exactly. It's more like they're taking existing materials, but they're arranging them in this super specific way, and it makes them behave totally differently.
So like water, right? It can be ice or liquid or steam, depending on how hot or cold it is.
Yeah, great analogy. So this topological superconductor, it has these things called Majorana zero modes, or MZMs, at its edges.
MZMs, huh?
Yeah,
Those sound pretty important.
they are. Imagine like a huge stadium where everyone is doing the waves. The wave itself isn't any one person, right? It's like the whole crowd moving together. MZMs are kind of like that. They come from how all the particles in the material are interacting.
Okay, starting to get it. So how do these MZMs help us build a better quantum computer?
Here's the wild part. MZMs are their own antiparticles. It's like a particle shaking hands with its mirror image, and that makes them super stable, which is like exactly what we need for quantum computing to actually work.
So they're like the tough guys of the quantum world,
Yeah.
ready to handle all the complexity and make it like actually useful.
Exactly. And to make them work, we do this thing called braiding. We move the MZMs around each other, like literally braiding hair, and that creates these stable quantum operations. It's like we're weaving the very fabric of computation.
Okay, so we've got these MZMs, they're in this new material, and we can braid them to make calculations. So what's the advantage here? I mean, why not just stick with, regular qubits?
Well, the thing is, regular qubits, they're super fragile. Like any little disturbance can mess them up and cause errors. But with topological qubits, the information is spread out over the like whole system.
So it's like having a backup for your backup makes the whole thing way more reliable, huh?
Right. And that built-in error resistance, it's like a game changer for quantum computing. It's a big reason why everyone's so excited about topological qubits.
This is where it gets like really revolutionary.
For sure. This is like decades of research finally paying off. It really shows that we can build a quantum computer that's, scalable and reliable in the future.
Now, I remember reading something about the topological gap. What's that all about? Why is that important?
Okay, so the topological gap, it's basically how strong that topological phase is. Like a bigger gap means the quantum information is better protected from like noise and interference. So you get a more stable and potentially faster quantum computer.
So it's like a shield protecting the precious quantum information from the messiness of the outside world.
Exactly. And the material they used in this research, which is it's an indium arsenide nanowire, and it's placed near an aluminum superconductor, that's what helps create this big topological gap.
So it's all about choosing the right materials, huh?
Totally. And this is where that collaboration between Microsoft Station Q and UC Santa Barbara, it's like super important. They have like world-class expertise in material science, and that was essential for this research.
And I think there were some specific researchers who played a key role here.
Yeah. Yeah, for sure. Chris Palmstrom, he's like an expert in electronic materials, and Suzanne Stemmer, she contributed her expertise in fabrication processes. They were both like essential to making this happen. It's really cool to see how, teamwork and collaboration can lead to these amazing discoveries.
Collaboration and expertise, that's the magic formula. But I gotta say, 8 qubits, it still seems kind of small, right? I mean, we're gonna need like millions for a truly powerful quantum computer.
Oh yeah, you're right. 8 qubits is still like very early. But the point here isn't the number of qubits, it's the quality. It shows that this approach, this topological quantum computing, it actually works. And it can be scaled up. It's kind of like, the Wright brothers' first flight. It wasn't long or fancy, but it showed that, hey, flying is possible.
So this is just the beginning of something truly incredible. But before we get into all the amazing things this technology can do, let's just take a moment to appreciate these researchers. I mean, the brilliance, the persistence, it's really inspiring.
I agree. It just shows what humans can achieve when we, put our minds to it and work together to solve these really tough challenges.
And for all our listeners out there, especially you, UPSC folks in India and all the quantum enthusiasts around the world, we hope you're as pumped about this as we are.
It's a field that's moving so fast, and the next 10 years are going to be, like, totally transformative.
We're going to be diving deeper into all those potential applications in just a bit. But first, a quick reminder to like, subscribe, and leave us a comment if you're enjoying this deep dive into quantum computing. We love hearing from you.
All right, so we're back. And before the break, we were talking about this huge breakthrough in topological quantum computing, right? This tech that could, like, totally change everything.
Yeah, the possibilities are, like, endless. It feels like we're on the edge of, like, a whole new technological era. So where do we even start with, like, what this could all do?
Well, how about with something that, affects everyone? Medicine. Imagine, like, designing drugs that are, like, super precise, targeting specific diseases, like, at the molecular level.
Right.
Quantum computers, they can analyze all those, like, complex molecular interactions that, regular computers just, they can't handle. So you could, like, totally revolutionize drug discovery and development.
It's like having a molecular magnifying glass.
Right.
We can actually see how those molecules are like interacting and design therapies that are more effective and have like way fewer side effects.
Exactly. And it goes way beyond just drug discovery. Quantum computers could like totally change material science too. We could design new materials with like specific properties, like lighter but stronger alloys for like airplanes and spacecraft, or more efficient solar cells for, renewable energy.
Okay, yeah.
We could even, like, maybe even create room temperature superconductors, and that would, like, totally transform how we, transmit energy.
Wait, room temperature superconductors. That sounds like straight out of science fiction.
I know, right? It might seem that way now, but with, like, the power of quantum computing, it could actually happen. And don't forget about, artificial intelligence. Quantum computers, they could, like, supercharge all those machine learning algorithms.
Right, right.
We could see breakthroughs in, like, image recognition, natural language processing, maybe even, develop machines that are, like, truly intelligent.
It's both, like, super exciting and kind of scary to think about,
Yeah, for sure. Like with any, powerful technology, we got to think about the ethics, right?
Yeah.
We got to make sure that we're developing and using quantum computing responsibly so that it, benefits all of humanity.
Right, of course.
But the potential for good is like enormous.
Absolutely. So we've got medicine, material science, AI. I mean, the list just keeps going. So what does this mean for like the average person? When can we expect to like have these quantum devices in our homes or, at work?
Well, we're still in the early stages, Building a large-scale quantum computer that's like commercially viable, it's a huge engineering challenge. It's kind of like building the first airplane, There are a lot of hurdles to overcome. But this breakthrough, it shows that we're on the right track. And things are moving faster and faster.
So it's not a matter of if, it's a matter of when.
Exactly. And when it happens, it's going to be like a total paradigm shift. It's not just about, faster computers. It's a whole new way of processing information and solving problems that we like never thought possible before.
I'm ready for that future. This is like a super exciting time to be alive. So what other like breakthroughs do you think we might see in the next like decade as this topological quantum computing keeps evolving?
Ooh, that's a tough one. It's like a wide open frontier, right? We might see breakthroughs in like cryptography,
Yeah.
like unbreakable encryption, or maybe we'll develop quantum sensors that can like detect tiny changes in gravity or magnetic fields. That would be huge for like geology and astronomy.
Wow, it's amazing to think about how these discoveries could like completely change how we understand the universe.
I know, right? Sometimes the most like out there ideas end up being closer to reality than we think. But no matter what happens, one thing's for sure, the journey of quantum computing, it's just beginning. And it's going to be an incredible ride.
This breakthrough with topological quantum computing, it's a giant leap forward for sure.
Yeah.
And it really shows like the ingenuity and persistence of all those researchers who have like dedicated their lives to this field.
Yeah, it's truly amazing. It shows what we can do when we work together and really push the boundaries of what's possible. It's all about creating a better future for everyone.
Okay, so we've talked about the science, we've talked about all the like mind-blowing potential, but I think the biggest question everyone has is like what's next?
Right. That's the million-dollar question, isn't it? Predicting the future is, always tricky, especially in a field like quantum computing where things are changing so fast. But I think it's safe to say that the next decade is going to be all about like intense research and development.
So what are some of the big challenges that researchers are going to be like tackling in the next few years?
Well, one of the biggest ones is scalability, right? Right now we're talking about a processor with like 8 qubits. But to really unlock the power of quantum computing, we need to scale these systems up to like hundreds, thousands, maybe even millions of qubits.
Yeah, and I imagine that's not just a matter of like adding more qubits, it's
Yeah.
about making sure they all work together,
Yeah.
reliably and in sync.
Yeah, exactly. It's like conducting an orchestra of like super delicate and sensitive instruments, maintaining coherence, managing errors, and developing like really efficient algorithms. Those are all like critical
I mean,
challenges.
there's a lot of work ahead.
There is,
Mm,
but it's an amazing challenge, and the potential rewards are like huge.
absolutely. So
Nice.
let's shift gears for a second and talk about accessibility, right? Right now, quantum computers are mostly used by like scientists and engineers, in research settings.
Mm.
So how do we make this technology more like widely available?
That's a really good point. It is kind of like an exclusive club right now. But if
Yeah.
we want this to, really change the world, we need more people involved, right? Definitely. It's like, what's the point of having this amazing tool if only a few people know how to use it? We need to figure out how to make it, user friendly, like developing interfaces and programming languages that, anyone can use. So researchers in all sorts of fields can, harness the power of quantum computing without having to like go back to school and get a PhD in quantum physics.
Right, right. So basically democratizing access, making it so anyone can, explore its potential. I like that.
Exactly. And this brings us to another like really cool area, hybrid computing. It's not about, quantum computers replacing our regular computers entirely. It's more about them like working together.
Okay, yeah.
So imagine a future where, you've got your classical computer and your quantum computer and they're like teaming up, each one doing what it's best at.
Like a dream team of computers, each with its own like special skills coming together to solve, humanity's biggest problems.
Haha. Yeah, exactly. And as this technology keeps developing, we're going to see it affecting all sorts of industries. I'm talking like personalized medicine, materials discovery, financial modeling, even things like mitigating climate change. The possibilities are like endless.
It feels like we're opening a door to a whole new universe of possibilities.
Sure.
Incredible.
Totally. And the coolest part is we're just getting started. There's so much we still don't know, and that's what makes this field so exciting. Who knows what amazing discoveries are just waiting to be made.
It's an amazing time to be alive, that's for sure. A huge thank you to all our listeners, especially those tuning in from India and all around the globe. We hope this deep dive into the world of topological quantum computing from that article in Science Tech Daily has, sparked your curiosity and left you feeling inspired.
Hmm.
Don't forget to like, subscribe, and share this episode with your friends. Until next time, keep exploring, keep questioning, and keep diving deep into the fascinating world of science and technology.